and welcome. You should be on page 21 of your Algebra 1 Quarter 2 notebook. In this video, we're going to be talking about graphing systems of linear inequalities. Actually, we're going to graph one system of linear inequalities by hand, but our main focus is going to be on interpreting those graphs. So, what is a system of linear inequalities? Well, just like a system of linear equations, you're going to have two or more, not equations this time, inequalities. And of course, my pen is going to just pause for a sec. Okay, got a new pen. So I was writing the word inequalities. So, like a system of equations, you've got two or more of something. In this case, I've got two or more inequalities. So how do I graph a system of linear inequalities? Again, like a system of linear equations, to graph it, what you'll do is you'll graph each inequality. So I'm going to do this one by hand, and we're going to see what that ends up looking like. So this first equation, x plus y is less than 5. Well, that is in standard form. So the most efficient way to graph that would be to use the x and y intercept method. So if I have x plus y is less than 5, I'm going to find my x-intercept first, which is the value of x when y equals 0. So I'm going to kind of not pay attention to that less than sign here. I'm just going to imagine y equaling 0, and what I have left is x equaling 5. So my first point is the x-intercept at 5, 0, where it crosses that x-axis, 1, 2, 3, 4, 5. My y-intercept will be the value of y when x equals 0. So again, I'm going to just see that y will end up equaling 5, and I have a point at 0, 5. So write out 1, 2, 3, 4, 5. Now, I've got my two intercepts, time to connect them. Well, unlike with equations where it's automatically a solid line, I've got to look at my symbol. This is a less than symbol, so that means it's going to be a dotted line. And if you remember from our graphing linear inequalities unit, what this dotted line means is that any point along this line is not a part of the solution set. The final element to finish up graphing this one linear inequality is to find out where do I shade. So I like to use the method called a test point. And what I'm really trying to find out is this point in the solution set? And my test point, if it can be, is always 0, 0. Why? Well, it's some fairly approachable math to do. So if I substitute 0 in for x and y, I have 0 plus 0 is less than 5. Is 0 less than 5? Well, yeah, that is a true statement. So for this particular inequality, 0 is a part of the solution set. It results in a true statement. So I'm going to shade it so the 0, 0 is included in my solution set. Now remember, any point in this shaded region is a part of the solution for x plus y is less than 5. All of these points will result in a true statement. Any point, however, on the line will not, and of course any point up here in the non-shaded region will not be a solution. Next step for a system is to now graph my other inequality. This says y is less than 2x minus 1. And I can see right away that this is in slope-intercept format. So let's get a starting point. And my starting point is going to be b, y equals mx plus b equals negative 1. Well, b is the y-intercept, or the value of y when x equals 0, y equals negative 1. So I should be able to start at 0, negative 1, right here. Now I know that m, this 2, is my slope. And I also know that slope is the change in y over the change in x. So I'm going to make this a fraction by putting a 1 under it. This tells me that I can go up to, right 1, up to, right 1, up to, right 1, up to, right 1. But let's be flexible in our slope thinking. Negative 2 over negative 1 is also equal to 2. So I could go down to left 1 as well. Down 2, left 1, down 2, left 1. Alrighty, I've certainly got enough points to graph. This is a less than symbol, so again, I've got another dotted line indicating that anything along the line is not a solution. Final thing for linear inequality is to find out where I'm going to shade, and I will do a test point. Is 0, 0 a part of the solution? Do I shade up here? Let's take a look. If I put in 0 for y and then do 2 times 0 for x, I know 2 times 0 is 0. So is 0 less than -1? No, 0 is actually more, so this is a false statement. 0, 0 is not part of this inequality solution set. So for this inequality, I'm going to be graphing over here. So hopefully you can see, I'm not sure the colors, I'm going to really color this point in, this area in as dark as possible. These are the solutions that meet both this inequality and that inequality. Again, anything along this line, not a solution. Anything along this line, not a solution. So my solutions are only within the boundary of the shading among the two. So we can pick any points we want. I mean, I'm just going to stay here right on the x-axis. I've got 2, 0. We could go 2, -1. There are infinite solutions to choose so long as they are in the shaded region. One thing to think about, this 0, 0 is not a solution. It meets the requirements for this inequality, but not that one. So it has to be a solution for both for it to be a solution to the system. Now, you might be pleased to know that you're actually not going to be required so much to graph these systems of linear inequalities for your assessment. What your responsibility will be is to interpret the graphs. And for that, you're going to use Desmos. So here we are in Desmos, and I am going to enter in these two inequalities. The first inequality is 2x minus 3y is less than, so I'm going to put less, and then I'll put the equal symbol, and that'll give me the less than or equal symbol, 6. So there's that inequality. Now, just note, this is a solid line. So this point right here, the x-intercept, 3, 0, is a solution to this inequality. The y-intercept, 0, -2, is also a solution. Now I'm going to put in 2x plus y is less than 2. X less than 2. Alrighty. So now I can see that here is this particular inequality. It's a dotted line. So this particular point is not a solution to this inequality. Everything in the shaded region is a solution. So let's kind of interpret this a bit. This point, 0, 2, is not a solution because it's a part of the dotted line. But this point over here, the y-intercept of the first inequality is a solution. It is where these two, right here, this triangle almost, part of the intersection piece. So -2, or 0, -2, is a solution to that inequality because it falls on the solid line around the double shaded region. This point here, of course, if you can see, -6, 0 is clearly a solution. Anything in this shaded region is a solution. Your job is probably going to be more likely to say, along the dotted line, not a solution. Along the solid line, solution. In a shaded region that's not shaded for both, not a solution. This gray and this pink, whereas the kind of red light color is definitely a solution. Now I want you to take a minute to just flip to page 23 because that's where we're going to finish our inequalities video. Let's take a look at this. This is a system of linear inequalities. It just happens to be 3. So I'm going to put each of these in here. I have x is less than 2. I've got, excuse me, y is greater than -2. So far right here, I've got this double shaded region here. These are dotted lines. So these surrounding the double shaded region are not solutions. And my final inequality is y is less than or equal to 2x plus 1. Alrighty. Now, if you can see, I've got the solid line right here. This is almost forming a right triangle. Actually, it is forming a right triangle. I've got 3 intersections right here in this right triangle. So 0, 1, solution. Negative 0.5 or negative 1/2, solution. Negative 1.5, negative 2, a solution. But right here, 0 or negative 2 is not a solution because it falls on the dotted line portion. 0, 0 is clearly a solution. So it's kind of interesting to see what are solutions and what are not. So now we can answer these questions. Is 0, 0 a solution? Well, I can actually just take the time to write it into Desmos. Let me just move this here. I can put label, and you can see clearly that 0, 0 falls into the solution set. So yes, it is a solution. Now let's see if 2, negative 2 is a solution. Look at that. That falls at the intersection of 2 of the dotted lines. It is not a solution. No. Let's take a look at this last problem, and we're going to see if we can find solutions and non-solutions. I'm going to just keep that labeled there. I've got 3x plus 4y, and press the plus 4y is greater than or equal to negative 12. And then I've got y is less than negative 3/4 x plus 3. Let's take a look at this. Now, this is a super interesting situation because you can see that these two inequalities, if they were equal signs here, would result in parallel lines, no solutions, right? But they're inequalities, so that kind of changes the scope of where our solutions might be. And you can see that for our blue, I was shading down here, and for the red, shading up here, and this purple, this space in between the two lines represents an infinite bounty of solutions. So let's see if 0, 0 is part of that solution set. I can kind of see that it is, but let's just prove it visually to ourselves that yes, it is a solution. And now we'll see 0, 3. And right here, it is on the dotted line. It is not a solution. So that's it for this video. Thanks so much. See you later.